Okay, now let's start our lesson. It's called a comprehensive tour through the Datex data model. First of all, I will start with some basic information about Datex and how to access the data model. This is of course not the data model itself. I think this is necessary to understand the things. I'm not sure if this is boring you. Please tell me if it is boring you, then we'll keep it shorter. Anyway, I will try to keep it quite short because the interesting things is the data model. And anyway, you can interrupt me and you can ask questions and we can extend things if you like to hear more about them. The question is if I can give a comprehensive tour, because the data model is quite large and actually I will have, of course you will get a good overview, but I will pick out some interesting elements and explain them more in deep, and others I will skip, but if you like to hear about them, we can do this, of course. Okay, a few words about me. I'm a computer scientist working in a very small company in Aachen, in Germany. And well, I'm working on profiles for Datex in the market, in the German mobility marketplaces. I did a lot of work there. And as you heard yesterday, I'm the editor of the parking publication. And this is a lot of work I'm doing now, right in these moments. Okay, this is so our workshop today, and there are some things for the next workshop already included. But what we are doing now is we are hearing something about the basics, and we are hearing our tour on the Datex level A model. And the next things below this are of the following workshop in this next session. Okay. I think you already heard about it. What is Datex II? This is some more formal, and well, you will get the slides, so I don't know if we need to go in deep here right now. What is important, we have a set of artifacts in Datex, and especially the data model is the thing we are concerned with today. We also have software to generate the schema. Okay. We also have a Datex tool to generate the schemas. This will I present in the next session. And there's also, of course, documentation on Datex available. Important, of course, is that Datex is based on the standards UML, XML, and HTTP transfer. And as you already know, I hope so, Datex is standardized. Meanwhile, we have got 5 parts. Yesterday I presented the upcoming part, number 6, parking. Okay. The Datex methodology, this is something which lies behind all the Datex information. It's a methodology document which is describing in a meta kind of model Datex. So we have rules how to proceed in Datex, and they are kept in this document. We have got 3 levels of meta information, which is the data on the lowest model side. We have the data model, which is interesting us today, and there is another meta model above. So the meta model describes how to describe the data model. These are the different levels. Included in this methodology document. It's freely available on the Datex website. I would say it's a document for specialists, but sometimes in my slides I will have this logo here, methodology, and this is a link to this document because then it's some kind of more formal. So what do we have of elements in our Datex version? The current version is version 2.2. There will be a version 2.3 this year, and the next big release will be version 3.0. 3.0 will not be backward compatible to the other ones. So if there is a minor version, they all are backwards compatible. That means in the minor version changes, there are changes of definitions or really smaller changes, so that is there no problem. But when version 3.0 is upcoming, this might be next year or over next year, I'm not quite sure. This is a major version, and there will be major changes, obviously. Each version consists of a set of different documents and things, and what we have is the data model, which is actually present as an enterprise architect file. We have this methodology document. We have a schema, which is a general schema. I will explain today that it is very useful to sharpen a schema and to make your own schema, which is smaller than the general schema, which is available here. We have the tool I already mentioned to generate these schemas, and we have an exchange specification, the protocol, how to exchange all the data. And then we have some informative documents, which are handbooks, documentation files, data dictionaries, everything like that. This is available too. Okay, and today our focus is on the data model. Yeah? So where to get all this stuff? The main page, of course, is datex2.eu. There you will find all the things you need, and you need a login for this. The registration is free, but necessary, and then you can get access to these things. There's only one problem. The website is crowded with spam from the not crowded with spam, but they have a spam problem, and so they had to fulfill the registration requests manually, and thus it does not work within a few hours. You have to wait a little bit. This is a website. You have access to some of the documents without logging in, but it's useful to have a login and to log in, because then you can download the latest version. Otherwise, you cannot get access to the latest version of Datex. Where you find it is in the download section, in the current version, and in the reference set. And exactly these 2 points of the menu are not visible if you do not have a login. And there you find the things I mentioned. You find some exchange specifications. You find platform-independent models. I think this is a screenshot from 2.1. Meanwhile, it's 2.2. What might be more interesting for you right now is the possibility to get access to the model in an HTML form for the browser. That you can do, of course, without any login or registration. So you can right now print it into your browser, and to open it, I can do this too, of course. I already did it. And this is the data model. The connection does not work. But as you can see it here, it's the picture is very similar to the enterprise architect model. Also the package structure, it's very similar. And actually it's another way of presenting the data model. One way is the model we heard from Jan Wiczynski before, and this one is the official Datex model tool where you can browse the packages and have a look what is inside. So it's a question of likeness, if you like this one or the one of Jan, or if you work with Enterprise Architect. Okay, here is again the address of the Datex browser from Jan Wiczynski. You already heard about it. When you like to develop Datex and when you like to work with it, you will obviously have to use Enterprise Architect, which is an UML modeling tool and which is available from Spark Systems. And if you like to view only, you can also download a free version, but the complete version where you can edit and modify things is not very expensive, so it's affordable. And with the free version, you can have a view on the model, but actually this is quite the same as you have in the HTML browser version. Of course, I will work with Enterprise Architect mostly to show you the things, and this is a view on the Enterprise Architect. you have to set some views in this Enterprise Architect tool to have the best performance on working with the model. This is the project browser which we need, and which is on these commands you can set the project browser. We will need the project resources, and we will need a window of tagged values. These are the three things which you need when working with Enterprise Architect. The first look at the model, you already saw this in the HTML view. This is the Enterprise Architect view. You see it's quite the same. This is the structure of Datex 2, and what we are talking about, there are some other packages, documentation, analysis, dynamic, and functional. They are not interesting for us. The interesting part is the logical package, and then the entry point D2 logical model. This is the interesting point for starting at the data model. I said in Enterprise Architect, this is the project browser. This is the project browser where you can see the packages. And here we have got another window you can see on this side now, which are the resources. And you see that there is a UML profile created for Datex 2. That means that is part of the data model. It was created by the Datex user community. And you can find some UML elements here. Of course, you know these names of the UML models. But they are a little bit, it's a special profile. So this is a predefined attribute. Of course, it's kind of a normal UML attribute, but it has got some special features, especially some tagged values predefined, and all the other things in a similar way. When you work with the model and when you want to create new elements, you shouldn't use standard UML model elements, but you should use elements from this UML profile to do it in the correct way. I talked about tagged values. This is the third view we need in Enterprise Architect. Tagged values are custom values with a tag and a value, yeah, so some kind of key and value system. We use it in Datex to express different things. Tagged values are attached to all kinds of elements, to classes, to attributes, to everything. And as you can see here, we have a quite long list of elements which we fill out with information. Some of them are more important than others. Very important is the definition tag and the order tag. The order tag is not visible here on this element, but most elements also have an order tag. The definition tag, as you can imagine, gives a definition. And this is, of course, quite important because this definition will be seen in the schema, and later on the developer can have access to this definition. And yeah, this is some kind of real important information, because here you say what the element does. It's some kind of truth what you write here. Yeah? When the definition does not match, you shouldn't use the attribute. Although you might think it's a nice attribute, it does what I need, but the definition says something other than well, you shouldn't use it, or you should find some other solution. And these are the tagged values of the root class, and here you can see we have some version information, some name information. So we have a lot of additional information packed into this UML model. Okay. Yeah, I said before, the most important tagged values are the definition for each component, attribute, literal, package, and an order information. The order information deals with the order of different attributes. For instance, if a class has more than one attribute, which is quite often, of course, then you need to order them. Obviously, you would say the uppermost is the uppermost, and then the others, you would deal it like that, but in Datex you have to explicitly say, I order them and I give them a number to get the correct order later on in the schema. You can also check the version of Datex in the class D2 logical model. In the starting point, you have a tag version, which is the version of Datex. And the current version is 2.2. 2.3 is coming this year. Okay, this is a kind of methodology. This is, a picture how to, which UML types we are using. I think you might all have seen them. We are using, of course, class elements with different aggregations. I have a very small slide for aggregations. I think the next one. So we are using classes, aggregations, multiplicities, which are very important, of course. And we are using enumerations and data types. And this package here is, this image here denotes a package. Okay, yeah, I said all this, I think. An enumeration, of course, consists of literals. And in the classes, you will find attributes, of course. So a very small example on the aggregations, at least. You might think of a car, and a car has got 4 tires, usually. Yeah? So we have the multiplicity number 4. So that means a car has got 4 tires. And this relation means a car might be of type BMW, for instance. And for instance, a BMW might or might not have 0 or 1. A parking assistant, and this parking assistant has got an operating status. This is mandatory because here is no multiplicity behind it. So when you specify the parking assistant, you might say if it's operating or not. Okay, this is really an aside. It's methodology. This is the meta model for the UML model. So here we have got in UML, we defined the UML models we use for Datex. So this is really for specialists. You will not need it in your daily work, but it's quite interesting to have a look at it in the methodology document. Then I think the last information is, of course, that we have different views. So if you see pictures of something, you always need to be aware that there are different views possible on these pictures. You can have a picture like this, a BMW, which is of type Cabrio, but this must not be complete. And especially this is no contradiction to the example before. On the example before, you saw something about tires and something about parking assistant. When you see this picture, the other picture is valid too. It's just another view and another part of the scene you are seeing right now. So there is actually there's no possibility to find the truth from the pictures, because there might be things which are not on the pictures, and you can find the truth in these property slides here. So you have got the elements in the tree, and you can have a look at the tree, and you see a point. This is the class point. This is here the class point, and the relationships of the class point, and you can see a point has got a lot of relationships to these elements. But usually not all of these elements are visualized in one picture. You can do this, but usually the picture will be very huge in this moment. And maybe you have a picture where you just visualize the LHC point, but the others are there too. And here you can see all of them. Yeah, this is important. This is an example for this. This is a view on the point item, which has got different, types of appearing by coordinates, by linear element, by LHC. And this is another view on the point item, which looks quite different, but is the same data basis. Okay, here is something. Of course, you're also able to visualize a component without any elements, without any attributes. Here, in this picture, there are no attributes shown, although there were mandatory attributes in this class. Here are mandatory attributes which you cannot see. You can do this. Of course, this is a little bit unlikely because people might not register that there are mandatory elements. But it's not forbidden to make such a picture. Okay, in Datex we use data types, but we created our data types our own. So, of course, we have very common things like string, booleans, and integer, and all these things are classes. So, for example, the string class, which is able to be restricted by some facets with the length. The string class will map to the schema type string, which means it's mapping to the to the basic schema type string, and so there is another, let's say, another layer of Datex. In Datex, you only use your predefined data types, and they are mapped to the final data types. So you don't use the simple types yourself, but you always use the Datex types. We have a lot of them. We have generic ones, which are shown here: boolean, float, integer, etc. And you see these are all Datex classes which are named like this. Yeah? So if you would have made some fun, we could have named this floating point number or something, and this maps to a simple type float. Of course, we named it float to have a good reference. We have specific data types of different kind. You see these are things which are needed in the surrounding of traffic data, vehicles per hour, axles per hour, and so on. In this case, they are non-negative integers. We have got other ones which are floats. As you can see here, kilohertz, tons, meters as floats, etc. Okay, another thing are references. The most common type of a reference is the aggregation. You say, I have a component and the part of the component is another component, so I directly connect them. But this is not always possible. Especially it's not possible when you have got two different messages. When you have got one, for example, a static message and a corresponding dynamic message, you cannot make an aggregation between it because they are not linked. Yeah? So there will be very different things of data you are sending. And that means you can, of course, make references in Datex. You do this with a stereotype, which is called version identifiable or identifiable. These are two possibilities to do it. And this means that this component, in this case here, we have got a measurement side table, becomes an internal ID. So it's an object you can reference. Yeah? You are not talking about some anonymous object which you cannot identify anymore, but you are talking about this special measurement side table. Usually, you should select this ID very carefully in your XML. It's always said it should be unique in space and time, so using a universal unique identifier is a very good idea for that. And on the other hand, of course, there needs to be a mechanism to reference it, and this is, it's a data type actually, which is called version reference, and there in the dynamic model you can set a reference to the static, for example. We can see this in an XML statement. We have a measurement side table, and because of its stereotype version identifiable, it has got these parameters ID and version. And as I said, you should use a unique identifier, so this is a quite very long number which is generated and which does not appear a second time, hopefully. And you can give it a version if you like to update this object. If there are new versions of this object, you can keep this ID and you can just improve or set up the version. The same here with the measurement side record. It has got another ID. And to reference it in the dynamic message, you can say here, this is my measurement side table reference, and you reference the class measurement side table with this ID, which is exactly this ID. And that means when some client computer gets this dynamic message with this information, he knows, okay, I have to look for a class measurement side table with this ID. And hopefully he has got something like a database, looks in it if he has received such a static message before. And if not, he might have to ask his server to deliver this static class, for example. You always do it with ID and version. And as I said, there is another possibility to do it without version. So you can have these two options with or without a version. Okay, this was the introduction. I hope it was not too long. Now we can start with the content. Yeah, I put this slide. Maybe it does not fit here. Maybe you saw it yesterday. Maybe you know it. It doesn't have too much to do with the data model. But in Datex, we have got 3 early parts which were standardized in Sen, and this is for, how much is it, 3 years ago. The newest parts were the variable message sign and the method and elaborated data. They have been standardized last year, and the standards were published this year. And in nowadays we are going to standardize the parking information. But what you can see are some, the names of the elementary parts which we are dealing with. Yeah, context and framework. This is something like the methodology, because this is standardized too. And all the other things belong to the data model. So we have got, of course, a very big part location referencing. Situation I will explain very in deep. And here are the other parts which are part of Datex. We are talking about the levels, the interoperability levels. You might have heard the distinction between level A, B, and C. Level A is, let's say, the existing data model. You can see it as a data catalog, as an ontology, or as a data registry. So some kind of Lego bricks you have available to build something you like. The level A model is fixed. It's part of the standardizations, and the Datex community decided only to adjust this with new Datex versions. So it's some kind of fixed truth. Yeah, that's maybe why Jan wondered how to often update his model. The Datex versions are renewed once a year in the minor versions, but they are not renewed too often, and the major versions are all 3 years or 4 years something. So this is not too often that there are changes on level A. But the interesting thing, of course, is to make extensions, because you are able to extend level A with a level B extension. And this is one very good point in Datex, that you can do this, that you can even do this backwards compatible to level A. I will explain this in my second session. And there's also the possibility to make a level C extension. That means actually you are not dealing anymore with the Datex level R, but you are dealing with the Datex principles. So you make something very new with an own namespace. So you don't care about what Datex elements you have. Maybe if you like to make some model for public transport which is not entailed in Datex, you can do this. So you are only using the Datex methodology. You can say it like this. For example, in Germany on the mobility data marketplace, we have a level C extension for the prices of petrol stations. And they said, okay, this is very special, and we don't need anything from level A. We make it completely new, but we like Datex, and we do it like this. And this is even mandatory for all petrol stations in Germany, meanwhile. Okay, you know this picture. This is the entrance into the Datex II data model. The main class is the D2 logical model. The class actually is situated here, and this is the package where everything is inside. And in the enterprise architect, it looks like this. You have got the main package here, and you have got, of course, sub-packages here with this yellow sign. You have got one special package for level B extensions, which is called extension. And these symbol marks figures and views. So this is, yeah, it's part of the model, but this is something you can deal with, and you can modify, and you can add. You can make as many views as you like. If you do not have the right picture, then you make a new one. So this is very informal, where the other things are formal parts of the model. And here you have the component. In this case, it's the main component of the model. Okay. Now I'm going through these packages. You saw them here, which packages we have. The upper packages we have is Exchange, Extension, General Management, and Payload Publication, and I will walk through them now. And if you are able to have a look in the HTML browser, you could follow these things, because it must be the same. Yeah, you can have a look in parallel. I don't know if you are able to do so. Okay, what do we have in the first package, in the Exchange package? In the Exchange package, there is protocol relevant information. So we have the type of subscription, some keep alive message, some delivery interval, some update method, and in fact there is no content related data, no traffic related data in it. The Exchange specification is currently updated, so there will be a new version. The whole Exchange document is in update progress and will be completely renewed. And most likely the Exchange package will not be part of the other data model anymore. Also most likely there will be two different things, one data model for the content and one data model for the Exchange. Here in this case it's still part of the data model, but it's yeah, it's under reconstruction, let's say it like this. Okay. The extension package. The extension package is a package for customized extensions. So for level B extensions you want to create yourself, you can place in there. Usually the extension package came empty, because the level A model does not have any extensions. But this changed since Datex version 2.0, because we started to develop the parking extension, which is an extension actually, so it's a customized extension, but the Datex community decided to put it into the extension package and to deliver it with the model. So it's still an extension, it's still a level B extension. It will be standardized as level B extension. This is some very interesting point too. But it's delivered with the official Datex version you can download from the website, so it's part of it. And in the current version, it looks like this. It's a little bit, yeah, let's say unsorted, because you have got no main package which says it's a parking extension. This will change. This is an early version of the parking extension. But these are all elements here from the parking extension of an early version, as I said before. But in the moment when you download version 2.2, the extension package will look like this. And what you can, of course, do you can delete all these packages and make your own extensions. If you don't like the parking extension, if you didn't need it, you can skip it out. Now the bigger packages, we have got the package general. In the general package, we have got the data types packages. I showed them before, you already saw them. We have the generic data types and the specific data types. Of course, we have got the very big group of georeferencing, so the group of locations, it's called here in Datex. We will have a look at it, of course. We have got the payload enumerations. This is a collection of all enumerations. Maybe I can show this in Enterprise Architect directly. Of course, this is the same. Yeah, I took the screenshots from here, of course. So what we have is the general package, And what we have is the payload enumerations. And as Datex has got a very huge number of enumerations, they needed to be divided by alphabet. Yeah, you see we have got here L2M or something, and there we have got some inside, and we have got here a lot of them. And all of them have literals, of course, sometimes more, sometimes less literals. You can see them when you switch them on here. And as you can see, we have an own package for location enumerations because there are some enumerations for locations itself. And if you have heard my speech yesterday about parking, the parking extension, the new parking extension, will come with 48 new enumerations, which is a quite huge number for just one new extension. So these folders will grow. Here, you remember this is a view on it, and here you can have a look on the enumerations. I don't know if they are all enumerations. Okay, these are only the packages, of course. Yeah, you see the enumerations entailed in the packages are visible here. Okay. This is the enumerations folder, the payload enumerations folder. Then we have a big folder, reusable classes. You can see there are a lot of subfolders and a lot of components itself. Reusable classes simply means these are components which are, they are not own publications, but they can be reused. They can be used several times in the model. These are some basic structures which you need probably often or more than once. You can see something like fault here. You can see something like data value here. We should have a look at it later, maybe. So we can go through it later on. We have a small management package which is used for the life cycle of situations. That means here you can say a situation is something like a traffic message, and here you can say when it is not valid anymore, when it is cancelled, when it is overridden. Usually Datex has a principle to only send valid information and to send all valid information. Also when talking about traffic messages, the principle is to send all valid traffic messages in one vector maybe. And when something ended in the next update, this message is not contained anymore. So the management package is a small arrangement to do it another way, to give explicit the information, something has ended, something has stopped, something was cancelled. You can do it with this management, but it's very, very small. It's only a few attributes. The most interesting packages, of course, is the payload publication, because here we are talking about the publications itself. So here you need to decide what to publish. If you are publishing traffic messages, if you are publishing measured data, if you are publishing variable message signs, this is your entry point to find the possibilities you can have in Datex. And of course, we'll have a more detailed view on some of them. You also can see that there is a generic publication. The generic publication is just an empty class where you can put your extensions. For example, the parking extension is attached in the generic extension. Actually, you can make level B extensions everywhere. It's not limited to a generic publication. But if your extension is a publication, it's useful to put it right there. You can make level B extensions inside publications. You can make a measured data publication, and somewhere in the middle of the data model you can say, I like to have here something, and you can make a very small extension there. But with the generic publication, you are able to make a new publication your own as a level B extension. Okay, what are the different elements? We have the elaborated data. This is data which is created through algorithm which is computed. I said before, this is an empty structure for extensions. We have the opposite to not the opposite, but the alternative to elaborated data, which is the measured data. in combination with the measurement side table publication. This is dealing with directly recorded data, mass data, if you so want. We have a predefined locations publication. That means when you are defining locations, georeference, you can define it just once, give it an ID, and reuse it later on. And to define a location, you use a predefined locations publication, especially in locations which are very huge, or areas which or things where you have got a lot of points to define. It's of course useful to define it just once. The situation publication, a very big publication with traffic messages, with operator action messages. I will explain this very in detail. The traffic view publication, which is a special view on a particular section. And the VMS publication, which is dealing with variable message signs. Actually, it has got a publication and a table publication. Actually, it's also a very big publication and quite complex and also interesting. Okay, now I try to collect the objects some more in a structured way. You see that yeah, most of the elements I explained before. We are deciding between objects which are only dynamic. So the elaborated data is an object which does not have any static part. You only have dynamic information there. You have got some traffic elements like congestions and accidents. These are dynamic too. The operator actions, network management, roadworks, these are dynamic information. Then we have got things which have got a static and a dynamic part. That means, yeah, that means they are separated into two messages, like parking to, parking. Okay, parking is written here too. But for these three things, you can have a static message, which is sent. Yeah, it might be sent once a year or something. Yeah, it's even possible to transfer it via file or via USB stick if you don't want to. Program a mechanism for the static information when nothing changes. On the one hand, and on the other hand, you need corresponding dynamic messages which might be transferred every minute or something like this. And then, of course, you have got a lot of additional things, which is the location referencing. Datex does not focus on one location referencing method, but it supports a lot of them. Of course, we have got the basic elements area, point, and linear in different methods with LHC, with this ISO standard 19148. Of course, coordinates, which are popular, of course. We are going for TPAC log, and there is a very good OpenLR extension. This is a level B extension, which is not part of the version you can download, but you can download this extension and include it. I think it's very useful, and it's used also. Then we have the predefined locations I explained before, and then we have some additional descriptions like lanes and type of road and something like this. And we have got other things. We have got a model for the validity of messages, for example. Of course, we have things like comments and URLs. Especially for traffic messages, we have got impacts, sources, and causes. And we have information about the data quality and its faults. When you go into the model, you can see these top classes. You can see the D2 logical model. And you have got the payload publication. Here you have got some attributes there. You also have the exchange package here. This is it's mandatory. This is a little bit unhappy. Maybe we will change it in version 3 because that means there are later on. You cannot see them here, but there are later on some mandatory elements about the international identifier you have to express in every message. But the most likely thing is to use a payload publication. Okay, yeah, I made the picture a little bit nicer to read it better. And the payload publication has got a lot of possibilities how to express. You might remember that this means it is an is specification, so the payload publication does not have all these elements, but you specify a payload publication which is of type this, or this, and only this small class here is a really aggregated class which you have to, some header information, yeah, to specify there. And all these things you see around here are the things I explained before. I think there's nothing new. Yeah, these are the elements you saw before, which are part of the payload publication. And we had this thing with the static and dynamic message, and we have a static VMS table and a dynamic VMS message, and here again, the static and the corresponding dynamic message. Okay, now we have a look at the situation package, at the traffic messages, at all. You remember this picture, and we are talking about this situation package here. Okay, yeah, this was the last one. The situation package looks like this at the upper level. And this means we have a publication, and we have unlimited situations. Here it says 0 to star, so we can put a lot of situations in such a message. And every situation message can have at least, I think at least one and up to many situation elements. That means this is a two-step hierarchy. So you can say the situation might be yeah, some road work, but there might be some traffic jam and some accident included. So if you are talking about things which are aggregated in one bigger situation, you will use a situation for this and then specify situation elements on this. And maybe you can see this when I go back. It's very small, of course, but these are version identifiables here. So that means it's, of course, very important that you can identify the situation and the situation element, because likely you will update them. Of course, if there is a traffic jam, you will send an update frequently when the length of the traffic jam changes. And this is, I explained the management package before. As I said before, usually you would send only these situation elements which are still valid and leave others which are not valid. But it's possible to make the information that something is cancelled with this management package. Okay, what does a situation have for information? You will have some information on the impacts. That means if there are lanes closed, if there are lanes blocked, roads blocked. You will have some information about the source of the message, who reported it, or where did it came from. You will have got information about the validity. I will show this validity model later on. You will have information about the cause. You can select between a list of causes, or you can reference another situation, because an accident might be caused by some roadwork or something like this. Of course, you have got here, as I said before, comments and URL information. And of course, the most important thing, you have got a georeference for the situation. That is quite clear. And as you can see here, of course, I do not write this explicit everywhere. But of course, everything is equipped with a lot of timestamps. Timestamps of the message, timestamps of the first occurring, of the first version timestamp, and so on. This is quite clear that we are equipped with a lot of timestamps. The validity model. This was one part of the situation model. Yeah, so you can specify a validity. You can do it very simple. You can specify a total period where you say, I have an start and nothing else. Yeah? So that means this is valid. This is possible, and of course you can specify an end when you know something will end anywhere. But you can go into deep. You can say, I include periods or I exclude periods. And these periods can be built up very complex. They can be built up with time periods within a day. And of course, you can specify the day. This is possible, so it's a very complex procedure. You can build up validity. I don't know if someone was in the yesterday's session where the guy from Parker said the opening times of parkings could not express something he wanted to express. I think that is not true, because the opening times refer to this standard model of Datex. This is the Datex standard here, and you can express it. I think he only read the part about parking, and in the parking part we did not explicitly say that there is the standard part, but it should be possible to do this, what he wanted to express. So that means what you can do is you can specify an overall period, you specify this period, and the resulting period is here in green. What you can do is you can specify an overall period, and you can specify some more valid periods here in green, and the result is an overlap between the overall period and the specified period. And when you do it with exclusion, you can say, I have an overall period, I have some valid periods, and I want to, no, these are another valid periods. Yeah, this is an overlap. So I have a valid period here and a valid period here. So the resulting period is the resulting of these two green periods. And when you do it with exclusion, when you say maybe there is a special week where this roadworks does not happen, yeah, then the resulting period does not contain this red part of the vector. So you have only here these green parts as a result. And as you can see on the left side, you can say some things like every first Monday in the month from 15 to 18, from April the 1st, etc. So it's possible to express all that. We have got the impacts. Yeah, as I said before, you can say something about remaining capacities, the number of blocked lanes, original number of lanes, partially blocked, carriageway blocked. This is possible to express with the impact. The cause, you have got a list of causes here you can choose from. It's not a too comprehensive list. You can imagine of more causes. We also had this requirement that also these are about 30 elements, but you can imagine more things which are not included there. And maybe we need to update this list. Usually you have got a literal other at the end, so you are able to specify at least something other. And here, in this case, you have got a cause description, so you can say it's a multilingual string, and so you can say what happens there. But of course, usually it's better to use enumerations than multilingual strings. Maybe the concept of multilingual strings. We are deciding between strings and multilingual strings. A multilingual string is a string which can be provided in multiple languages. So that means I can, when I give an attribute here, I can say in German it's an Unfall, in English it's an accident. I can give as many languages as I like to give. And usually this is used for the end user or for some possibility to display it. When you use the data type string, it's usually more an internal information, like some identifier or something which is not presented to the public. The other possibility to express a cause is to use a managed cause and to say, I make a version reference on another situation record, yeah, maybe some accident which happened before and we already have information about it, then I can reference it here. Okay, yeah, I always forget, but I made it a little bit nicer. I showed before the elements which are part of a situation record. Now I'm showing the elements. The situation record can be, the situation record is of one type, and it's of one type of these three elements here. So a situation element is a non-traffic related situation, it's a traffic related situation, or it's an operator action. These are the three possibilities. And now we will see this in another form. So here on the left side, we have got, again, non-road information, traffic element, and operator action. And you have to read this from the left to the right. So that means when you are talking about a non-road event information, this might be a car park, for example, a roadside service disruption, road operator service disruption, or transit information. These are the possibilities for this non-road event information. For a traffic element, you can talk about conditions, abnormal traffic, equipment or system faults, about accidents, of course, obstructions or activities. And these can be even more precise here on the right side. So it's, these are all specifications of the element. Yeah? So if you want to talk about weather-related road conditions, you only choose the element weather-related road conditions, and this is everything else. So my situation is of kind weather-related road condition. Yeah? This is the only thing you are going to code. You do not code that's a traffic element and conditions and road conditions. This is only the path to come to this element. And as you can see, yeah, we have weather conditions, we have non-weather conditions. You can see that there are sometimes numbers and pluses. That means that there are more submodels behind. So that means here are 6 more components, and these components have another submodels included. Especially here I can show this. This is the poor environment condition, and the poor environment condition can inform about precipitation, about visibility, about pollution, about temperature, about wind. And you always see here some symbol. This does not work here in my slides, but in Enterprise Architect, you can continue on this sign here to another submodel for temperatures, for example. Then you have, I think, temperatures in the air and on the ground and something like this. So there are things which are very, where there are very big submodels behind it. We are talking about abnormal traffic. For the abnormal traffic, we have this enumeration. Usually this is, especially this enumeration is a good element to discuss about, because the number of stages is usually very different. There are some other standards with 3 stages or with more than 5 stages or something, and it's not too easy to map them. Yeah, you might think this is very easy, but this is always a challenge, and sometimes even a political discussion how to map these enumerations from different standards. We have general abstractions. Yeah, as you can see here, a whole list of things: air crash, explosion, etc. We have road maintenance. I only show the enumeration here, what is possible to have road maintenance possibilities. But as you can see, I did not show this here. The roadworks component has 3 more components, so it's possible to define more things here. Here it's only the enumeration you can see, because usually the very last elements here in this list, there are only enumerations. But there are, especially for roadworks, you have got more components to specify it more in detail, of course. And you have got here things like general network management, bridging, obstacle signaling, traffic lights, etc. Maybe the roadwork is an interesting topic I can show in Enterprise Architect. I will have a look what comes next. Okay, this is georeference, yeah. Maybe I show more about the roadwork. This is the situation record, and I'm going to the operator action and into the roadworks. Of course, you have got more information. You did not saw them on the slides before. You have some information about the duration, about its scale, if it's long-term or short-term, or big or small one. if it's working under traffic, and here you have got more information. You can specify the subjects which are part of this roadworks. You can specify moving maintenance vehicles. If the whole thing is mobility, so if it moves itself, the roadworks. And then you can specify that you saw in the slide before if it's construction work or if it's a maintenance work. So all these things, you can imagine that all these classes we showed before have got elements similar like this, so you can really define a lot of things you like to do. The georeference, of course, is a very big theme to have a look at the georeference. We have the most upper class, the group of locations. That means you can specify more than one location. Here you have got the location. You can make it, of course, you can do it as a single location here, or you can do it as an ordered group of locations, or you can do it as an ordered, non-ordered group of locations. And what you can do is you can give coordinates for the visualization, for a map, for instance. You can do it by reference. Yeah, when you previously defined a predefined location publication, you can just go and set, okay, my reference is this and that's it. But the most usual thing to do is to specify one of these three to a point, a linear or an area. And yeah, you have additional description, as I said before, something like footpaths, carriageways, lanes or something. For the example of the point location, all the others are very similar, linear and area, but I'm going to have a look at the point location. You have got several methods. You can specify it with coordinates, where Datex is using the ETRS 89 system, which can be also populated with VGS 84 coordinates because they differ not too much. And you can add a bearing and coordinates for visualization. Another method is the point on a linear. That means you define some linear element. You can do it with several methods. You can do it by coordinates again, and you can do it by ID. And then you set the distance between the starting point and the point you are looking at. You give it. So this either method is another methodology to denote a point on a linear. Yeah, you might know ALAT-C, of course, the location code lists, which are national lists with tables where you can find different points, usually only very important points like motorway junctions or something. Then you have the possibility to code it via TPEG, and as I said before, which is not part of level A, but there's also an OpenLR extension for points, which can be downloaded from the website. There is an extension folder on the website, and there you find the OpenLR extension. Well, I'm specifying these methods here. I don't know if this is interesting too much. It's what I said before. Yeah, you can do it by coordinates. Here you have got the model for the coordinates. I don't think we should use this now too much. This is the point on a linear. You are looking at a point which is located on some linear. This is the model behind it. Well, but maybe it's more interesting to look at really content. This is ALAT-C with some information. You will get these slides and you can have a look at it. I think it's not too worth viewing here now. Okay, you wanted to make a nice photo, or I can, yeah, I can. Maybe I've got a nice slide. Don't know. Maybe this one. I don't know. Okay. On the last slide, you saw that there are a lot of links where you can find all the stuff for the for using all these Datex things. Yeah, actually we are at the end, but maybe we can have another look in the model itself here on the browser. The measurement side table, wait a minute. Okay. Maybe the measurement side table publication. This is a publication, I said, which is static and dynamic. And you have got some table, which is actually some hierarchy of information. And you have got side records. Actually, this means some boxes. You can say these are the measurement boxes situated on the road. There's a lot of information, especially about the equipment type which is used, of course, something of a name. You can specify the lane where it's situated and the direction. And such a box has got a lot of measurement values which it can produce. This structure is some special structure. It does not mean that there is just one characteristic, but it means that there is an ordered set of characteristics. So when there is something like an index, it's always a multiplicity from 0 to unendlich, to unspecified number of elements. And here you can specify what elements are recorded. For example, wind, for example, speed. All these things are possible to characterize here. You can specify the vehicle characteristics, which is valid for. So you can say I'm measuring the speed of lorries only. And of course, you have got the group of location information here to specify where this thing is situated. And this is the static information. Yeah? So you say, OK, here I have some measurement site which can measure the speed of lorries. And now what you need is the dynamic information. And the dynamic information, it needs to have a reference, which is right here. You specified the reference on the static, and here you say, OK, now here comes my dynamic value, which refers to the static information. And here you put in the values you are measuring, your measured values, actually. Of course, you have got again, some equipment type use. You can override some static informations. And you have got basic data. And the basic data might be of type traffic status, traffic data, weather data. Travel time data is another thing we have here. And all these can be explored. So here in the traffic data, we have information about the headway, about the flow, about the speed, about the concentration. Maybe let's open the traffic flow. And here I've got different values. You can specify the axle flow, some other flows, and the percentage of long vehicles, for examples. And here you have got the values. Then you might notice here, this class has a small link to the data value class. We can have a look for the data value class. Maybe here the TumTum browser is a very useful thing because searching in this tool is possible, but it's not too convenient. No. The data value information is an information which is entailed in nearly every kind of data value. Yeah? Here you see all the data values we have. And all these data values have implicit information about some context information about data errors, about reasons for the error, about inaccuracy. You don't need to specify this. Yeah, you can say the lorry percentage is 50, but you can also say, okay, this value is erroneous, and this is erroneous because of something. So implicit, every data value you use, you can accompany with a lot of information here. Yeah, I think so far. And as I said, it was hard to come through the model. There is, for example, the VMS model, a quite interesting model, but a quite complex model. Yeah, but I think, and I hope you have a nice overview of this topic, and yeah, I hope you liked it. And yeah, in half an hour we continue, and then we will show, or I will show, how to make profiles and extensions.
Yeah, I have one question. In my organization, we have more or less extensive work within data modeling, using two standards, more or less overlapping standards, Datex and Inspire. Both are using the UML modeling tools, both are using enterprise architect. But when it comes to, that's my impression, when it comes to design principle, ways of modeling more or less the same things, there are differences, which in my organization creates confusion, because people say, why should we have, for example, this enumeration here, which is modeled differently in the other standard, and both standards will be used. Do you have any cooperation attempts to align with in terms of data modeling?
We have cooperations with TPEC, where we have the same problem, yeah, with all the TPEC enumerations, and there we started to make to make some services which can map these things. Actually, we started to make some mapping tables. With Inspire, I don't know. I don't think that there are such corporations right now.
But this is a major European activity, and there are overlapping stuff. So
I know that this is very difficult. Yeah, as I said before, let's say if we have an enumeration about vehicles, it might be very simple. Yeah, small children might say, "Oh, it's the same. It's no problem. Yeah, it's a car and it's a vehicle, and let's say it's the same." But it's not. Yeah, and these are even political questions, how to map these enumerations. Yeah, it's you can make a lot of things wrong when you say I map it like this, and people are screaming, "No, we don't like that." It's very difficult, yes, and it's a major problem. That's true.
Because when it comes to implementations, you have to support two different types, applications, two different standards.
Yeah, it's difficult for the implementators. Yeah, of course. Yeah. Any more questions? Okay, fine. Then thank you very much for being here.